Assalamualaikum friends, today I am going to show you by hacking LED driver circuit how to adjust the brightness, how to regulate voltage, and by this combination making of crazy projects. Hello viewers, myself Adnan Sani and you are watching my channel Electric Shop. First of all, let's see the constant resistance. This is constant resistance. Now check the original brightness. Now we will reduce the brightness by increasing the value of the resistance. I have already changed the resistance to 3.0 ohm. Now you can see brightness is greatly reduced. So if you increase the resistance, brightness will be reduced. Before it was 1.5 ohm and now it is 3.0 ohm. Here is the LED driver circuit. Somewhere you will find constant resistance in parallel and somewhere in single, but should be the lowest resistance. So constant resistance always connects to pin number 8 and it will be the lowest resistance for the whole circuit. Typically this resistance value between 0.9 to 1.35 ohm. Now voltage regulation. Voltage sense pin always connects to pin number 2 in relation with ground. Higher the resistance, higher the voltage. Here as you can see, I am decreasing resistance and voltage is decreasing. And increasing the resistance, voltage is increasing as well. So it's time to make project. Here 32 pitch LED. All LED are in series. LED forward voltage 2.9 volt, load current 28 mA, so voltage required 92.8 volt. But LED driver I am using gives 120 mA, so I have to hack constant resistance and limit the voltage. To make you understand, I have taken LED strip to calculate constant resistance. In datasheet you can see there is 400 mV voltage difference with the comparator linking to the CS pin. So when current flows through the CS pin, there must be 400 mV voltage drop that limits the current. But the driver I am using was unable to find datasheet on the website. So don't worry, we can calculate reference voltage. This is constant resistor and resistance value is 1.6 ohm. Now power up. It is taking 124 mA. So voltage difference got 198.4 mV. This driver default output current is 120 mA. We want to flow 89 mA. With the reference voltage by calculating, we got 2.2 ohm resistor. Now I am using 2.2 ohm resistor to flow 89 mA current. If the reference voltage is covered, it must flow 89 mA current. Oh, it's flowing 89 mA. So our calculation was right. So finished. Bye bye. Not yet. Picture abhi baki hai mere dost. As we have modified series resistance, we have to modify voltage resistance as well, because if line voltage increase or circuit malfunction can increase the voltage. So if you don't do so, the result is I have damaged all LED. To set the voltage feedback resistance, just take out install resistor from board. Take 200k variable part and slowly increase the resistance. Now flickering. When LED glows, stop to rotate the variable part. Desolder the part, take multimeter probe to measure the value of resistance. This is 10k. In this way, you can get feedback resistance. As I said earlier, for 32 pitch LED, voltage 92 and current 28 mA required. Yes, it is taking to 28 mA. Voltage 91.2, quite good. This LED is set to the back side of mirror. It's looking nice. On the basis of this theory, you can make RGB LED bulb. Hopefully you learned something from this video. Please subscribe my channel, hit the like button, and thank you for watching.